This question is number 12 on our review, so I should write the number 12 instead of 11. And it says that it is third degree. Actually, I should say what it actually says. Okay. Construct a polynomial with these stated properties. So we got to come up with a polynomial. Anything in the world, but it can look like anything. It just has to make sure that it's third degree. It also says it needs to have zeros of -3, -1, and 2. So we got to have those zeros, and we also have to pass through this point. And so it's got to pass through this point 310. So the lucky thing is that we can wait on this. So let's take care of this part first. So since we have 3 zeros, it's automatically third degree. So that's really stupid to say that, right? Sure, we'll call them stupid. So if it has these zeros, you can write the factors. So x plus a 3, x plus a 1, x minus a 2. That's a polynomial. And that would be it if we could just not talk about this point that it has to go through, right? We could say that f of x equals this. That's a polynomial. Now, if I plug, we're going to come back to this now. If we plug a 3 into this for x, we got to get out of 10. That's the idea. So I'm going to plug a 3 in here and see what happens. Hopefully I get a 10. That'd be awesome. This would be sweet if it works. So 6 times 4 times 1. Is that right? Can I add? I can add correctly. Awesome. Does that give me 10 though? No. Dang. What's that give you? 24. So if I plug in a 3, I get 24. I don't want 24, do I? What is it that you want? You want a 10. You wanted a 10. I really wish that 24 was equal to 10. It'd be sweet if it was, right? Do you know here's what we could do though. I mean, I just wrote this down. I mean, I'm just trying to write a polynomial that has these attributes. So we could really, like this x plus 3, x plus 1, x minus 2, we could write whatever we want to down. I mean, I could take this and multiply it by any number I wanted to out in the front. So what if I had this little letter A out here in the front, like another number out in the front? It's kind of like this little sneaky number. So I'm going to put another number out front. I'm just going to leave it to be an A. So if I knew what this little sneaky A was, and if I picked it just right, if I picked this A value just right, I could times it by 24, and it would make a 10. That'd be super sweet. Do you know what that fraction would have to be? Could you turn 24 into a 10? I don't know what it would be off the top of my head. But how do you solve the little A times 24 equals 10? How do you solve that? How do you solve for A? You divide by 24. Five twelfths. So we're going to take this 5/12 and we're going to stick it right up here in front. Or I'm going to rewrite it, I guess. And there's my polynomial. So now when I plug 3 in, what's going to happen is I'm still going to get 24 out of this, right? But I've got this 5/12 on the outside. And if you take 5/12 and times 24 by it, you get 10. Right? Does that make sense? So it's sneaky. There's a little sneaky Pete out here. And you got to figure out what sneaky Pete is. That's it. This is a polynomial just like any other polynomial. The answer key has gone and multiplied this all out. The answer key has. But you don't have to. Because we don't discriminate against polynomials around this part of the country. We don't take too kind of them kind of people around here. So does that make sense? That's awesome. What was that, number 12? 12 on the test review.